So these first 5, I just wrote up as the class was working. I'm going to take a picture and post it so you can always check your answers for those. So down here, we're getting into the domains. If you were to graph this f of x, what would it look like? For number 6, that f of x, what would that look like? Yeah, it would be quadratic. It's a parabola. That's going to be all reals. As a heads up, all reals is a very common answer for these. What a lot of people do when they get this quiz is just go and fill in all the ones that are all reals, and then it looks like you filled in a lot of it already. All right, and then this one, it shifted right to, so it would be bracket 2 to infinity. Now, don't forget to actually answer the whole question, though. We want where both of those are. So it's f plus g. Now, if one of them's all reals, you can pretty much ignore that, and your answer is just the other one. Hey, Ms. Cole, do I have to rewrite that? Well, kind of, yeah, because I need to know which one's your final answer. Okay. For this one, for f of x, who is your troublemaker? Who are we kicking out of the domain? 4. Get rid of 4. 4 is a problem. And then this, if you graphed it, what would it look like? Just use your imagination. A line, good, which will be all reals. So again, if one of them's all reals, you pretty much ignore that. Your answer is just going to be the other one. And again, yeah, you kind of have to recopy that because I need to know what your final answer is. All right. Who's your troublemaker for this one? Who are we kicking out? -6 is not invited to the domain party. And then this one shifted left 10, so it'll be bracket -10 to infinity. Now they both have a restriction. So you want where both of these are happening, or basically where they overlap. So you want to do -10 onwards. So we're going to start with -10, but you also need to skip over -6. So you're doing both of them at the same time. Let me make that look more like a 10. So again, when you're doing the f plus g of x domains, it's just you combine both of them. That's all that it is. And if one of them's all reals, then you pretty much ignore that. All right, now here we're getting into composite functions. This is like our telephone game. These first ones are just with numbers. You just have to go to the correct function first. So when you look at this one, which is the inside function, f or g? G, do you see how the inside there, g of 0? If you plug in 0 to function g, what is your output? What do you get back out? -3. That's going to get passed along, like the telephone game, to function f. You need to write this step. Because a lot of like the number arithmetic is going to happen within your brain, and I can't grade what happened in your brain, so you have to at least show me that step. Now we're going to plug -3 into function f, so come with me on this one. -3 cubed. Well, think what's 3 cubed is 27, so make it -27. Still together? Double that. -27 doubled. The -54 plus 1 is -53. All right. And if you had to do 27 doubled off to the side, like this is valid. I mean, you sometimes need to do that. Okay. Do a margin problem. Which one is your inside function for part B? Inside. Are we all awake here? You were all really animated a second ago, and then when I started going over it for the recording, we all like went to sleep. Which one's the inside one? F. Okay, so you're going to plug 2 into function f. Ready? 2 cubed. 8. Double that. 16 plus 1, 17. So you're going to do g of 17, and I do need for you to write out that part. So we're going to plug 17 in right here. This is going to be fun with fractions. When you plug 17 in there, a fourth times 17 is just 17 fourths minus 3. But you need to write that as fourths. And walking around, this went well when I questioned everybody. How many fourths is 3? 12. So 12 fourths. And then you can combine, like you have a common denominator now, you can combine them together. So 17 fourths minus 12 fourths is 5 fourths. So sometimes fractions happen, okay? You can also use the same function for both of them. That's fine. Just do the same one twice. F of 1. All right, ready? 1 cubed is 1. Double that, 2 plus 1 is 3. So now we're going to do f of 3, which we already kind of did because we did -3 over here. 3 cubed is 27. Double that is 54, but it's positive this time. 54 plus 1, 55. Now I'm going to show you what I was talking about with these last ones here, because the domains of the composites always scare everybody. Save them for last. To be really honest, if you can't get those, but you get the rest of the quiz, you're still going to have a good grade. All right. So let's do everything else except that, and we'll come back to it. What's your domain for F on number 10? Perfect. Perfect. And then this one, all reals. All right, let's go down. Who's your troublemaker on this one? 2. Leave out 2. See, do all the ones that you know first, and then you'll have pretty much almost the whole thing filled in, and that'll calm you down. This one's linear, so all reals. This one is also all reals. G of x would be bracket 9 to infinity. It went right 9. All right, number 13. Who's your troublemaker for this one? 3. Leave out 3. And then what shape is an absolute value? V shape, so that's going to be... What do you notice about these? They all have one that's all reals. And it's a point for each blank. So that's 4 points right there. That's like automatic. All right, let that calm you down. All right, now all of these are f of g. That means g gets plugged into f. All right, so let me come back to number 10 here. This is going to get plugged in over here. Now, the trick is knowing how much to simplify and when you need to stop. Okay, if you take this whole thing and plug it in there, I'm just going to write down below here. It'll be square root. In place of x, you're going to put that whole thing, x squared minus 3, and then plus 5. Now, there's not a whole lot you can do with that, but there is one more step. What can you do to simplify that? Yeah, like terms. So it'll be square root of x squared plus 2. You can't go any further because the squared is only on the x, so just stop. Now the domain, which one's the inside? If you were tuning me out, tune back in. This is like the stuff we did last time. G, does G have a restriction? No, great. Fantastic. What did you guys say? Hallelujah? Great. Okay. Does F have a restriction? That's where you have to set up a problem. Hey, G of X, you better stay bigger than -5 or else no dessert. All right. So you're going to take this G of X, this x squared minus 3, and you're going to say, hey, you better be bigger than -5. Do you see the symbol I used there? Greater than or equal to? You better stay bigger than -5. And then you just see what happens. We're going to just see what happens and see where that takes us. The radical, yep. Greater than or equal to is if it's a radical. As a heads up, do you see this one? Is going to be the not equal to. Yep, that's how you tell. Now, what would you do to start trying to solve that? Don't force it to be anything. We're just going to see what happens. All right, plus 3, that would give you x squared greater than or equal to -2. And then you would want to do what next? But this is negative. You can't square root a negative. So we got something that is always true. If you square something, it's going to be positive. That is always going to be bigger than a negative. It's always true. Again, this is like when your parents are like, hey, I thought I told you to do your chores. You're like, I already did it. Geez, like you're already in compliance. It is already true. So what do we put as the answer? All roots. It's going to be everything. It's already in compliance. All reals is a good guess if you have absolutely no idea. All right, let's try this one. We're going to plug x plus 8 in over here. All right, so I'm going to remove the x and in its place, put x plus 8. Again, there's not a whole lot that you can do there, but there is one step of simplifying. So what will that combine to be? Yeah, good. It'll be 1 over x plus 6. Now, this one, to be real honest, I wouldn't bother trying to set up a problem. I would just look at that and go, who's the troublemaker? Because you know how to do that. Don't do it the easiest way possible. Who's the troublemaker in this one? Yeah, -6. So just get rid of -6. I would just suggest doing it that way. Don't set up a whole other problem. Because you can just look at it and see what the answer is. All right, here, we're gonna plug G, this whole thing, into F. So it's gonna be square root of x minus 9 squared plus 6. Now there is a little bit that we can do there. What would be our next step? Perfect. Cancel those out. That gives you x minus 9 plus 6. And that would just be x minus 3. So does G have a restriction? Do you remember what that means? If the inside one has a restriction, you keep it. Does the outside one have a restriction? Hallelujah. That means this is just your answer. You just copy it over. Whatever the inside one is, that was your answer. When there is an absolute value, you will not be able to combine anything. You can't combine what's inside an absolute value with what's outside. So you will not be able to simplify this at all. Just take that absolute value and plug it into the other function. Please don't combine them. I know I'm saying this, someone's going to do it. Don't combine those. With those bars, you can't put anything into them. Does G have a restriction? No. Great. Does F have a restriction? Hey, G of X, you better not what? You better not equal 3 or else. If I see you hanging out with 3, we're going to have problems. All right. So you're going to take G of X, this absolute value of X minus 2, and say, hey, you can't be equal to 3. And then you got to remember this from algebra 2. Remember how it splits and you get 2 answers? You with me back there? Okay. So you're going to have X minus 2 can't be 3. And then your teacher put the negative on the left side, right? Is how they did it. So it would have been negative X plus 2 can't be 3. Is that how they did that? Okay, I do it differently than that, so that always throws me off. But I want to do it the way you learned it. So are you getting what I'm saying? Okay, you're negating all of that. All right, and then you would add 2, so X can't be 5. For this one, you would subtract 2, you get 1, and then divide by the negative. So X can't be -1. So you have 2 troublemakers. You have done this before successfully. You've been good at it. You have to skip over both of those numbers. So it's going to be -infinity to what? Good. Perfect. I was hoping somebody would get that. -1 union. Yep. -1 to 5 union. Okay. Humor me for one more second. I get a lot of people that are like, nope, not doing that, Miss Cole. I'm just not. They dig in their heels. They're like, I'm not going to work that out. I just simply am not going to do it. You know what? Honestly, fine. You can figure out these numbers if you guess and check long enough. Watch. 5 minus 2. Absolute value of 3. 3 minus 3. Okay, look. -1 minus 2. -3. Absolute value, that is 3 minus 3. If you sit there long enough and try numbers, you'll eventually figure out which 2 are your troublemakers. I'm just saying, because I do get people that are like, no, I would just work it out personally. But I'm just throwing that out there because I want you to get the right answer.